Hi guys, this is a solution of FRQ 3 of AP Precalculus 2024 exam. This is no calc by the way, so let's get started. The tire of a car has a radius of 9 inches and a person rolls the tire forward at a constant rate on a level ground as shown at the figure. There is a point there's a point W on the edge of the tire touching the ground at time 1/2 second. So this W point, when it comes at the bottom, it touches at 1/2 seconds. So although the W is indicated, uh, you know, at some other place, but sorry, what they want to say is this, the when the W comes over here, that touches at t equal to 1/2. Obviously, because at t equal to 0, it is somewhere over here. So at t equal to 1/2, it comes at the bottom. And then once again, it comes at the bottom at 5/2 seconds after a full rotation. So don't you think this information is given to us to so that we can find the period? Because just with this much information, we can say that the period is going to look like um, 5/2 minus 1/2, because that is the time between one complete rotation, which is 4/2, which is 2 seconds. So from this information, we just figured out the period. Now the maximum height of W above the ground is 18 inches, which makes sense because radius is already 9. So 9 plus 9 should be 18, which is the maximum. And as the tire rolls, the height W above the ground periodically increases and decreases. Now the sinusoidal waveform is given. The graph of H and is dashed midline for 2 cycles as shown over here. No scale is indicated, no axes are present, Determine the possible coordinates of the 5 points F, G, H, K, and P over here. Okay, all right. So because the point t equal to, we know that at 1/2, the point uh, is at 0, right? Because the ground is the reference. So at the reference, the height is 0. And I know that the midline is over here, and the midline is equal, the height of the midline is same as the radius, which is 9 inches. And the maximum is already given in the question as well, which is 18, which we could have otherwise figured out as well. So I know that 1/2 comma 0 corresponds to a point. It cannot be this. I mean, it could have been this, but then these points will, kind of go in negative. So it doesn't really make any sense to make that. So what we can do is we can make the point J as the other point, which is 2.5 seconds, comma 0, which will make sense. So this is 2.5 comma 0. And now we can go a quarter back because the time period is 2, which means every from minima to the midline, I will go a quarter or t over 4, which makes 2/4. 2/4 is just 1/2 or 0.5 seconds. So I'm gonna go back by 0.5. So 2.5 minus 0.5 is obviously 2. And the midline height is just 9. We already agreed on it. We go 0.5 back and then we end up at 1.5, and the maximum height is 18. And likewise 2.5 plus 0.5. So the point K is going to be 2.5 plus 0.5, which is 3 comma 9, and then once again 3.5 comma 12. So this was pretty, sorry, not 12, 18. So this was pretty straightforward. All right, now write the function h as sinusoidal as a sine function where ABC, so find A, B, C, and D. So I think D is already known to us. That's just the representation of midline, which is just 9. A is the amplitude or the distance between the midline and the maxima, or the midline and the minima. So we can clearly see that the midline and maxima and midline and minima are at 9 units up, 9 units apart. So A is going to be equal to 9. 2 pi over B is going to be the period, and the period is given as 2. So the value of B comes out as 2 and 2 is gone. Cross multiplication, flipping the omelet, B is equal to pi. And finally, the value of C. So I know that the value of C is, if it's a sine function, and sine function was supposed to start from um, 0 over here, 0 over here, but this point is 1 comma 9. This point is 1 comma 9. Uh, so we can think about it like this has been translated to the right by 1 unit, and whenever something goes to the right by 1 unit, we do minus, we do subtraction inside. So the value of C is -1. So these, in fact, there are various answers. In fact, this, and this, these three will not change. These three will not change. But for C, you can have various answers. If you have a different one, please, you can, post it on the comment section. Maybe we can discuss about it. But this is about it. And the last one is for that, I need to pull up the curve once again. So give me 1 second. Let me pull this up. Okay. Now they are saying that between T1, which is at K, so over here, and P, which is here, which of the following is true? Clearly, this is the function is positive because this is the 0 or the x-axis. Now we know it's above the x-axis, so it is positive. And clearly, it is increasing in nature because with increase of x, y is increasing. So it's option A, very clear. And option A. So, and for question number 2, they are saying that this describe how the rate of change is changing. So we can clearly see that this is a frowning phase. So this is a frowning phase, which means that this is a concave down, and in concave down, we know that the rate of change decreases. The rate of change decreases between K and P. So this should be our final answer. I hope this makes sense, and we'll see you in the next video quite soon. Bye-bye.